Number 2, we have one proposed mechanism for ozone. You see here we have 2 steps, and we have one classified as a slow step, one classified as a fast step. So we'll go into more detail about slow steps in just a bit, but for right now, just know slow steps are your rate determining steps. Meaning that this first step, since it's the slow one, determines how fast the entire reaction occurs. Part A here, write the overall balance equation. So we're going to add together these 2 steps. Cross out anything that appears on both sides of the arrow. So we're going to cross out NO2s, NOs, and rewrite anything that is left over. Okay, there's my overall equation. Part B, which species is a catalyst? A catalyst first appears as a reactant, then later in the mechanism as a product. So I'm looking for one species that first appears as a reactant but then appears as a product, and that's going to be our NOs right here. NO and O. And catalysts always end up getting canceled out of that mechanism to get the overall stoic of your reaction. So our catalyst is NO. Part C, which one is the intermediate? An intermediate first appears as a product, then later as a reactant. So an intermediate gets made. It's kind of that in-between product from one step to the next one. So our intermediate in this reaction is going to be the NO2s. First appears here as a product in step 1, then appears here again as a reactant in step number 2. So NO2 is our intermediate. Okay, so recap. You add the equations, you add your steps to get your overall equation. Your catalyst is first going to be a reactant, and then it later comes out as a product, and the intermediate is the opposite. It first appears as a product and then later as a reactant.